Welcome. This is Math 3 Compression, Unit 16, Day 4 notes. And you can see right off the start, it's talking about circles again. So I'm going to write down, just as a reminder, the circle version of an equation. So a circle at the origin looks like this. And a circle not at the origin looks like plus y minus k squared. Okay. So while there's these two specific ones, you don't necessarily have to focus that there's two different ones, because even if you do have a circle at the origin, you can still use this equation. So it's actually, this is just the equation of a circle. Now, they specify at the origin, not at the origin, because h and k here, h and k represent the center of the circle. And if h and k are 0, you just would put in x minus 0. And if you're subtracting x, a 0 from x, you would just end up with x to the second power. So really, whether it's not or at the origin, you're welcome to use this equation no matter what. This one can also be used if you like to focus on that as well. So just as a reminder, when we are not at the origin, you're going to be given two numbers here, h and k. R stands for the radius. So if it's to the second power, it means the radius value was squared. So if the radius was 4 to the second power, the radius squared would be 16. You're going to see different situations with these now. So I'm going to draw a picture here. And it says, write the equation of a circle with the following properties and draw a picture. The center is -7 and 8. H and k is already here. So if I'm like, hey, I'm writing an equation, so I have x subtract -7 squared, and then y subtract 8 squared equals r squared. Well, we're essentially 3/4 of the way there. We know the h and the k. I could simplify this a little bit. I could say x plus 7 to the second, and then y minus 8 to the second. But I don't know the radius yet. And that's where the second part of this problem comes in. So this circle, I'm going to draw a quick x-axis, y-axis here. I'm going to draw... All right, so x and y, and here's the origin, that's 0, 0. Just to give you a kind of idea of where it's going. So 1, 2, 3, 4, 5, 6, 7. So this is -7. 4, 5, 6, 7, 8. So 8. So I have a center of a circle here at -7 and 8. So from the origin, -7 to the left, 8 up, just like we've done since we're probably in elementary. So -7 and 8, there's a center. Now, this is going to be tangent, so it's going to touch this. X equals -11. This is a line. So I got x is -11, so I'm going to find -11 on the x-axis, which I need to make some more numbers. 8, -9, -10, -11. So this line, the graphene, this is a vertical line here. This is the tangent here. All right, so in theory, I'm going to go through some of my words. That's okay. I have a circle going like this, evenly spaced around that center point, as best I can to not make an egg-looking shape. Okay, so I have a rough sketch of a circle. So from this, I'm going to need to determine the radius. And if I know the center here, and if I go out to this tangent, this would be my radius, but I got to figure out how many units that is. So if you think you're good with this and you're like, oh, I can count them out or figure it out, great. Count them out and figure it out. Pause. See if you can get it. And if not, we're going to go through. So this is at -7 here. So it goes from -7, it goes -8, -9, -10, -11. So it's going from the center out to this tangent, which is going from -7 to -11. So the radius is going to be 4 units long. Now, a radius of a circle is always positive, so it's always a measurement of distance. You don't need to say, well, it's going -4 units to the left. Well, a radius of a circle stays constant, stays the same, so it's always positive no matter which direction you take it. So if you can figure out the radius is 4 there, I'm going to plug in 4 from my radius and do it to the second power, and I have my equation of x plus 7 squared plus y minus 8 squared is equal to 16. So, little tricks and tips. If you need to make an x-axis, y-axis, count the stuff out visually. So it's a lot easier to see sometimes. Now, especially on this next one. So there's a circle whose centered is located in the first quadrant. So completely in the first quadrant. So nothing in the second, third, or fourth. Now this time I don't know the center. I have its tangent to x equals 4, x equals 10, and y equals 5. So let's see. First quadrant again. All right. So here's my x and my y. Y. All right. So tangent lines. X equals 4. So 1, 2, 3, 4 on the x-axis. I'm making a line, a vertical line, and this is x equals 4. I'm just putting the number there to remind myself of what that is at. I have another one here at x is equal to 10. Okay, so x-axis 10. So 4, 5, 6, 7, 8, 9, 10. I have another line going straight up and down through those. So this is 10. All right, I have a third line now, y equals 5. So 1, 2, 3, 4, 5. So this line, this is not going to be up and down. It's going to be side to side. So this is 5 on the y-axis. Now, let's see here. I gotta have this circle completely, I need to touch all 3 of these. I need to touch all 3 of these lines I made. So x equals 4, x equals 10, and y equals 5. Now, it has to be completely in the first quadrant. So I could make it down here, but it looks like it's gonna kind of ooze into that fourth quadrant underneath. So I don't want to make it here because tangent means it's going to touch all of them. And it's going to touch these 2, but not this one. And I can't have it up here because it's going to touch these 2 and not this one. So I believe it's going to be up here. All right, so I need to make a circle, which I have in the first quadrant. I need the center and I need the radius to make my equation. So when you start looking at this, you look for the 2 lines that are parallel that are touching each other. So I have one here at 4 and 10. Okay, if I make a line that cuts completely intentionally through the middle of my circle, this is the diameter. So if I go from 4 and then to 10, again, my diameter is a measure of distance, how far it is across. The diameter is 6 units. So if I know my diameter, I can divide this by 2 and get my radius to be 3. So my radius is 3. That's helpful. So if my radius is 3, this means it has to be 3 units away from either edge. So 4 plus 3 or 10 minus 3 would give me here. That would give me how far over it's at. So from 4 to 10, 3 over would put me here in the middle at 7. So that's the first coordinate of my center. So thinking about the origin, you have to go how many ordered pair, like an ordered pair, how many to the right or left, and then how many up or down. So I start here at the origin, over here to 7. Now you gotta figure out how many all the way up. Well, if I know this line is here at 5, and this radius is 3 more, so 5, and then I go 3 more up, this is up here at 8. So 7 right, 8 up, gives me my center. So I have an equation x minus 7, and then y minus 8 equals to 3 squared, or I really do want that number squared. Don't leave it as an exponent of 2. So I'm going to leave it at 9. That's really what I'm looking for. All right, this next part is called completing the square. I want these, see you have all these x's, y's, and other numbers. I want all these to look like this. All right, so this means I'm going to take my x's and I'm going to keep my y's, and then I'm going to have another number. So I'm kind of containing my x's together. I'm keeping my y's together, and then a constant or number without x and y I'm going to have on the other side of the equation. Now this is called completing the squared, and we did this in math too. We split up x squared to x and x. We divide the number 8 by 2. And I put not the 2 there, but I divide 8 by 2 and put, well, it's positive 8 divided by 2, so I put plus 4 and plus 4. Now, I'm going to do the same thing to the y in just a second, but I have to be careful. So if I just multiply this back out, I have x times x. I have x to the second. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. So I got 8x to the second plus 8x, which is what I started with. That's great. But I have this adjustment thing. I ended up, when I made this parenthesis, I did 4. I have a 4 times 4, which is going to add 16 to the problem. So when this happened, when I made these two parentheses, I added 16 to the problem, which is fine, as long as I do it to both sides of the equation. So if I add 16 to the left, I'm also going to add the 16 to the right. This is called completing the square, separating these into parentheses, but there's always going to be an adjustment number that's added into the problem. It's not a mistake. It's just something when we kind of change the form, I'm going to have to multiply these two numbers together and see what number I added to the problem. And whatever I do on the left, I have to do on the right as well. So what's going to happen is when these two should be absolutely identical. So I have x plus 4 to the second. Now that's starting to look like a circle. Now I'm going to do the same thing to the next one. I have two parentheses. Y squared splits up to y and y. I'm going to take this negative 4 and divide by 2. Split it in half between my two parentheses. And that's always a plus sign in between. And when I do this, I get y to the second. I'm just multiplying out to see what I ended up with. And then plus 4. Y to the second minus 4y, which is great. That's what I started with. But I had this extra 4 in the end. So that's my adjustment that I actually added into the problem. So I'm going to add it into the other side. Now, if you can get through all that, you're good, because all I'm doing is finishing it up now. I have my two parentheses. They're identical. So I have x minus 2 to the second I'm adding up my numbers here. Negative 16 plus 16 is 0. Plus 4 is 4. Hey, there's the circle. All right. The center, and then pull out the center and the radius. The center is negative 4 and positive 2. And the radius, so r squared is 4, so the radius is a square root of that, so 2. All right, so on letter B, it seems like a lot of work, but when you get through it, it's just this kind of very much repeating patterns. So letter B, I'm working through x squared minus 8x. Sorry, 18x. I'm going to do, and then I'm going to do y squared minus 10y. All right, so when I do this, I always set up 2 parentheses. X squared is x and x. Then minus 18, I'm going to divide by 2. Don't worry about the x. That's okay. It'll be there. Minus x. Sorry, minus 9 and minus 9. So I'm splitting that negative 18 up evenly. When I did this, I get x to the second minus 9 and minus 9, which is negative 18. I have this adjustment of negative 9 times negative 9, so this is plus 81. So I added 81 to both sides. When I made this, it's fine, but I have to do plus 81 to the other side as well. And then y and y here. Negative 10 divided by 2 is minus 5 and minus 5. I got y to the second, minus 5y, and then negative 5 times negative 5 is plus 25. That's my adjustment number, so I need to make sure I add 25 to the other side. All right, so I'm grabbing my calculator. I'm adding up these numbers, negative 6, 81, and 25. I get 100. So I'm simplifying everything. So x minus 9 to the second plus y minus 5 to the second equals 100. The center is at 9 and 5. This is r squared, so the radius is the square root of that at 10. All right, so the next one's, again, now I have 2x squared. Oh, whoa, I got 2x to the second plus 4x plus 2y squared minus 4y equals 14. You know what? These numbers are bigger than I want. So everything, and I mean everything, is divisible by 2. So I'm going to divide it by 2 and get rid of it. Make it easier on myself. All right, so 2x squared divided by that is x to the second. 4x and that is 2x. 2 divided by that is y to the second. Negative 4 divided by that is minus 2y. And the other side is 7. All right, make 2 parentheses. X squared splits up, x and x. 2 divided by 2 is positive 1 and positive 1. My adjustment is this times this, so it's plus 1 here. And I add 1 to the side as well. Feel free to pause at any time. If you're working through it on your own, you want to do it, absolutely. I suggest you try them on your own and then double check. Take the negative 2 divided by 2, I get negative 1, negative 1. My adjustment in here is negative 1 times negative 1, so plus 1 on both sides. All right, so we got x plus 1 to the second, and then y minus 1 to the second is equal to 9. There's my circle, and then my center is at negative 1, positive 1, and my radius is 3. All right, letter D here starts off the same way. Ooh, I gotta move this 260 over, so I'm gonna subtract 260, move it over. 5y squared minus 20y, negative 260. Everything is divisible by 5, so I'm going to get rid of that 5. Make the number smaller. Always easier to work with smaller numbers. All right, so 5 over 5 is x to the second. And feel free, if you're good in pausing, go pause the video so you can try the work on your own. Negative 260 divided by 5 is negative 52. All right, start making your parentheses, x minus 7 and x minus 7. Y minus 2, y minus 2. Oh, need my adjustments. Negative 7 times negative 7 is 49. Negative 2 times negative 2 is plus 4. All right, so I have x minus 7 squared, and then y minus 2 squared is equal to 1. My center is at 7, 2, and my radius is 1. All right, that's just a lot of algebraic. There's a little bit of steps, but as you get going and practice, it's called completing the square. It's just a lot of patterns over and over again. Now, the last of this is talking about tangents. All right, so flipping over to the back, example 2. It says circle A is shown with a center at the origin and a radius of 5. Point B lies on the circle at coordinates 4 and 3. So this is point B. The tangent to the circle is that B is drawn. Okay. Write down the equation of the circle below and show that 4, 3 is on the circle. Okay. So the center is here at 0, 0. So I can write an equation of a center at 0, 0. It told me the radius is 5. Move that over. All right, so I got x minus 0, and then y minus 0 is equal to 5 squared. So I'm going to clean this up. If I subtract 0, I just get x to the second. Y to the second is equal to 25. There's my equation. Now, it says show that 4 and 3 must lie on that. So x is 4 and y is 3. All we're going to do is plug in. So I do 4 to the second and 3 to the second. I'm trying to see if it equals 25. 25, and 25 is equal to 25. So the numbers I plugged in, when I square them and add them, they equal the same as what the radius is squared. So the two sides are equal, so it's on the circle. If it was less than the 25, it would be, the point would actually be inside the circle, so not on the edge. And if it was bigger than 25, so bigger than the radius squared, it would be laying outside the circle. Now, the slope of A to B. You are welcome to count the lines, rise over run. Or you can do the slope formula, y2 minus y1 over x2 minus x1. 2, 3, but I'm rising and running. So the slope from A to B is rise of 3 and run to 4. All right, so back to beginning of this unit. When a radius hits a tangent, joins a tangent, hits a tangent, meets a tangent, then we get a right angle. We get a right angle, which means perpendicular lines are formed. And perpendicular lines for the right angle here have opposite and reciprocal slopes. Okay, so I have the slope here. For this, the slope is 3 over 4. Now this tangent line's running the opposite way. So instead of going up as a positive, the slope here for the tangent is going to be negative. And it's running the reverse direction. So I say negative 4 over 3. That's going to be important. Anytime you have a radius to a tangent, this is what's going to happen to the slopes. So the slope of the tangent is equal to negative 4 over 3. So once I have one, I can always work to get the other one. Now I'm looking also for the equation of the line, and I have 4, 3 to use and point slope. So point negative 4 over 3, so it's y equals m times x minus, it's kind of like the slope formula has some x's and y's in it, but it's this y equals m parentheses x minus the x value plus the y value. That's what I'm looking for. All right, it says it appears, I'm not going to worry about this. Don't worry about that. Just more plugging in. All right, so let's look at this. Consider no circle here, but consider a circle whose equation is this. So right away, I can pull out the center. I can say it's 6 and negative 3. 1, 2, 3, 4, 5, 6, 1, 2, 3. And a point A, which is at 2, 5. All right. Show A must lie on the circle. 2 and 5. 3, 5. Here's A. All right, here's my center, and there's A. All right, I have this equation. When you're showing stuff for the equation, when it's asked you to show stuff, when it asks you to show that the slope, the point, whatever lies on there, you're always plugging it in. So if A is at 2 and 5, I'm going to plug in the x and the y into my equation and show that does the left side equal the right side. So I plug in 2, then I have minus 6 squared, and I have 5. 3 squared is equal to 80. Question mark? So I got negative 4 to the second plus 8 to the second equals 80. Maybe closer. 16 plus 64 equal to 80. Yes. We are good. A is on the circle edge. All right, so find the slope of the line segment that connects the center. So it goes from 6, negative 3 to 0.2, 5. All right, I could count, but I'm concerned I'm going to miss my line, so I'm just going to do the slope formula. So y2 minus y1 over x2 minus x1. I get 8 over negative 4, so I simplify to negative 2. Okay, so this has a slope of down 2, right 1, down 2, right 1. Looks like it fits. Okay, so this huge circle, this is my radius. Now it says there's going to be a tangent at A. So there's going to be a line heading like this. Like that. So the circle is going to be formed like this. Definitely off my grid. Woo! Big radius here. And anytime, so this radius here is going to hit the tangent. So this is the tangent. If this slope is negative 2, I can automatically get the slope of the tangent as positive 1 over 2. There's the slope of the tangent. So I'm going to use that slope in the A at 2, 5 and say your equation y equals 1 over 2 x minus 2 and plus 5. That's the equation there. All right, so last one here at number 4. So given the circle whose equation is -4 and 2, right away my center is at -4 and 2. Write the equation of the tangent to the circle at 2, 12. Okay, quick sketch here. -4 and 2, there's my center. 1, 2. Okay, so this is going to be my radius here. So some circle spinning around, whee, all around here. All right, first I need the slope of that one. It looks like it's going to be positive. It's rising to the right. So I'm going to do the slope formula. y2 minus y1 over x2 minus x1, 10 over 6, which is 5 over 3. That's a slope of the radius. All right, so I got my first slope. The tangent's going to come here and connect with that radius. It's going to make a right angle. It's going to go, I'm going the opposite way, so the slope is automatically goes from positive to a negative, and the fraction flips. 5 over 3 to 3 over 5. All right, so the slope of tangent equals -3 over 5. And I'm going to use the point 212. And now you just write out an equation. Y equals slope x minus 2 and plus 12. All right, so try your hand at these next ones for the homework. Yeah, try the homework, the rest of this front and back. Let me know if you have questions.